Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's easy Fillomino puzzle. It's not Sudoku, so keep that in mind. This is another type of puzzle. And it's called Fill, and take that easiness with a grain of salt first of all, because these is considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people here, particularly in Fillomino. If you've not done a Fillomino type of puzzle, then this could actually be very difficult. I'm not sure, though. Anyways, the title of this puzzle is called Fill-some-ino. So we have to fill some of the puzzle, and I guess that this is the part that we're not filling, right? So it's black, because we need to divide the white cells into regions of size 1 and 9. Sorry, 1 through 9. And fill each cell with a number representing the size of its regions. So say this was a size 4 region here, then we would have to fill all, we would have to fill, I don't know how I got there. We would have to fill all these cells with a 4. And that's an example of how Fillomino works. We also have regions. This is all part of the Fillomino rule set. Regions of the same size may not share an edge. So you can't have size 1 region here and then another size 1 region here, because they would be sharing an edge, and they are regions of the same size. Some region borders have been given. So this is one region border, this is another region border. And each row, n, numbered 1 to 9, top to bottom. And similarly, each column, n, numbered 1 to 9, left to right, must contain n distinct digits from 1 through 9. Huh. So that means row 1 must contain 1 distinct digit from 1 through 9. Row 2 has to contain 2 distinct digits from 1 through 9, etc., all the way up to 9 distinct digits in row 9. And the same thing is for column 1 and column 2 and column 3, etc. Interesting. Huh. Yeah, those are the rules. So it uses a little bit of like Latin squares. Well, not completely. No, it's not really Latin squares either. It's just a Fillomino puzzle. Anyways, those are all the rules. If you'd like to play along, I don't know if I said the author. This is Fill-some-ino by Afraid Not. I don't think I said the author. Apologies for that. I usually do, but sometimes I get so I usually get like distracted by the title of the puzzle. So apologies for not saying your name before. But this is Fill-some-ino by Afraid Not. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. We must have 9 distinct digits in row 9 and in column 9. Well, that tells us, so first of all, these have to be all boundaries because of the distinct digits. So we know this is a 1. This cannot be size 1. This can't be size 1. They have to extend out. So we're going to mark the ones as, I don't know, we'll make them dark. These have to be the same region. We know that for certain. This is a different, this has to extend out. This has to extend out. So therefore, these are going to be boundary here. So then these have to be 3. So we have to have 3 there. We'll mark that as green. Let's make ones light here then. We're going to have to use all the different colors. So this is going to be light. 3 will make dark. These can be up to 5. Well, so this has to, okay, so this has to go out here as a region. This has to go out as a region because none of these can be 1 through 9. There have to be at least 2. So therefore we know this is a boundary, this is a boundary, this is a boundary, this is a boundary. We have in row 8 also 8 different digits. So this same in column 8. So therefore these are all, we already have the duplicate. So this must be 5 and 5. This could be 2 or so. This is 5 and 5. It has to extend out. We know all of these are going to be the same digit because in column 1 and in row 1 there's only one distinct digit. One of these can be 2. So these have to be the same, guaranteed. So this has to be the digits 2 through 9 here. This is at least 6. Because these all have to be the same digit. These have to be the same digit, so it's at least 9. So this is 8 or 9 here. This is 6 through 9 here. Can this go out here? So this is either going to be 2 or 7 here. If it's 7, so these are going to be the same. So we have the same here, we have the same here. Obviously, this can't be, so, if this is the same, how does that work? Well, if this is the same as this, the problem is we have 3 unique digits, or sorry, 3 similar digits here. And we need to have 6 more distinct digits to give us 7. So therefore, this can't be part of these. These have to be the same distinct one, and then we have the same problem here. So then this would force a boundary here, which would force this to be 5, but then in row 7, we would not have 7 distinct digits. We'd only have 6 at most, because we have a 5 here and 3 5s there. So this cannot be connecting this and this. So this has to be blocked here, which means this is 2. So this is 2. This cannot be 2 here. It has to be 7 here. So this is formed as a region. This is medium. This is red. 7 is going to have to go to one of these cells, right? Because this is a boundary here. So we're guaranteed 2 cells that are the same. These 2 cells have to be the same. We can't have 4 cells be the same, because then we don't have 7 distinct digits. So this also must be 2. So we have 2 there. Seven. Okay, the problem if it going here is, so if this is going this way, it has to go to here. Because the problem is in column 7, if it goes here and here, it can't go any more here because we already have 2 copies used up, and then we have 5 more distinct possibilities as possibilities. So this could be 7 and it goes that way. And that could work because 6 would have to have 6 distinct digits. These would all have to be distinct. Can we go 7 here? No. If we go 7 here, this would be 2 and 2 as size 2, and then we would not have 9 distinct digits in row 9. So 7 does have to go this way. It has to go here, and then it goes to here. And that's done as a region. So then these are all 7. That means we have already 2 duplicates in... we have to have 6 distinct digits here. Interesting. Well, the 9 has to go out here, or both. And it cannot go... So if it goes 9 here, the problem is we can't have more than 4 other duplicates in column 5, and same with row 5. So this has to form some sort of pattern here, and I think it has to be this pattern then, right? Because you can only have 1 more duplicate in row 6, right? Because we have 2 duplicates already, and this one has to go either that way or that way. So assume it goes this way. We can only have 1 duplicate in that direction because we have 1 unique digit, 2 unique digits, 3, 4, 5, 6. So 9 going this way then means you can't go any further. You have to use all the duplicates here. But then the problem with that is we need another set, right? We could do something funky like this. No, we can't. So say we tried going up for the 4 duplicates. Or even partly up. That's not going to work because this has to basically be the same set here. But say we did even partly up here. The problem is we only can go up 1 here because then we use up all the duplicates in column 6. And then we have to go here, but then this already uses 4 of the duplicates in row 5. Yeah, it's just basically going to be problematic. So it has to be blue, blue. Well, actually, yeah. Because this is 7, 7, we have all of these have to be distinct digits. There we go. So that's helpful there. Same with this. All of these have to be distinct digits. We have our duplicates in... So this can't be 7 here. Right, so the problem is... we're going to have to go both directions. Well, okay, so 5 has to go this way. So that's one thing. So this is 5. You could potentially go 5 there. 3 cannot be any of these digits here. So these have to extend further. Well, there you go. So then this has to extend further. This has to extend further. This has to extend further. Same with this. None of these can be 3. This can't be 7 here. So none of these can be 3 in length, so they all have to extend 1 further. So this goes here, this goes here, this goes here, this goes here. Which means this is a 4 Fillomino. Again, this as a 9 has to go here and here. But the problem is, if it goes here, then this would be 1 as a singleton, which is not allowed. And we'd have 5, yeah. It basically, if we tried to go a certain amount here, yeah, this is all the same region. This is all the same region. So therefore, they must be all the same region together. So this is 9. So that's blue. Therefore, it cuts off here. This is all 4, which is green. Remaining digits. So this, we have duplicate 6 again. This can't be 9, so this has to be 8. So since this is all 8, it's done as a region. The remaining digits here are 4 and 6. Okay. In row 9, we have a guaranteed, so this has to go 5 here. So this is 5. That's done as a region. So this is pink. We have one of these goes 4 and then closes off. The other one goes 6. We have in row 9, we have 9 distinct digits. In row 8, we have 8 distinct digits. In row 7, we have 7 distinct digits. In row 6, we have 6 distinct digits. In row 5, we have to have a 6, and then we have to have something else. We're not sure. This can't be 9. So this is 6 or 8. For this same digit. This has to be 6, 5, 6, or 8 here. Which means one of these is going to be 5. But either way, these are distinct digits. So we have, this is distinct, that's distinct, so this must be 6. So we have to have 6 here. Which means this is 5 or 8. And if this were 8, we'd have only one distinct digit in row 2. So this cannot be 8. This is 5, which makes that 8. 5 can only go 5 here. So this is 5. And you have to have only 2 distinct digits in row 2. So this can't be 5, because then you'd have another 5 region sharing an edge with this 5 region. So this must be 8. 8 has to continue out here. So we have yellow here. This is pink. This has to be orange. We have 8 here. This is 6. We have to have 4 distinct digits here. 5 distinct digits in column 5. Okay. 4 distinct digits, 3 distinct digits in row 3. This is 8. It has to go out as an 8. So this is 8, which means we have 3 distinct digits in row 3. So these are separate regions. We have 8, 8 here. We have only one 8 here. But we have to have an 8 here. That's 8 and 8 is one distinct digit. 4 and 4 are, that's a second one. We have 3 more spaces left. We have 2 distinct digits here, so these are the same. This could be a 1. Column 3 has to have 3 distinct digits. We have 4 of them here. Guaranteed. If that's 6, so what happens if this is all 6? If this is all 6, these have to be distinctly different digits. So we'd have to cut off there. This would obviously be cut off there. Then this would be 6. This would be 4. So that looks like that works. This would have to be a distinctly different digit. We have... These are the same. Okay. So we have 3 distinct digits here. Well, this could be 8, 8. Okay. One of these is going to be a 6. We don't know what the other one is. So say we did have this as 6 here. If this is 6, this is 4. We need 2 more distinct digits in column 3. Therefore, this would be boundary here, boundary here. This would then be 6, so that would be done as a region. This would be 1. And the problem is the 8 would have to go here or here. I guess no. So if we had 8 here, so if we had 8 here, that would, this can't be 8. Because if this is 8, we have only 1, 2, 3 distinct digits here. So this can't be 8, it must be part of this region. So 8 would have to be here, but then this would be 8, 1. This would be 4. And we'd have only 2 distinct digits in column 4. So that's why this cannot be 6 here. This has to be 4 here, which makes this 6 there. So this is boundary necessarily there. This is all orange, and orange has to go out, so that's 6. We have... Wait, that's too few in column 4. Huh. Interesting. What happens? So, okay, again. Ugh. 6 and 4. We need 2 distinct digits here. So then this is 1. Oh. So this has to be 6 here. This is 4. We tried the other way and that wasn't working. But this can be broken up into multiple regions. Well, this has to be the same digit. So it's at least 2. But 8 has to form a region. It can't be 4 as a set. So we have 8, 3. I think that works. So we have 8 here. Yeah, that works. So that's what it has to be. Because we showed that the other way does not work. This is blue, green. This has to be 2. And this must be 3. 3, and that's 1. So those are the regions then, right? We should have one distinct digit in row 1, 2 distinct digits in row 2, 3, this is going to be 3 distinct digits in row 3, 4 distinct digits in row 4, 5 distinct digits in row 5, that's 2, this is 3, 6 distinct digits in row 6, 7 distinct digits in row 7, 2, 4, 5, 6, 7, 8, 9, 8 distinct digits in row 8, no 1, 9 distinct digits in row 9. 9 distinct digits in column 9, 8 distinct digits in column 8, no 1, 7 distinct digits in column 7, no 1 or 3, 6 distinct digits in column 6, no 1, 2 or 3, 5 distinct digits in column 5. This is not enough. Oh, that's problematic. Okay, so that's not going to work. So then 8 has to go here. Oh, this could be 8. No, we need 3 distinct digits. Dang it! What's going on? Did I? I'm not good at Fillomino, so but I don't know if this is a Fillomino thing or if it's just a I'm screwing up thing. You have to have distinct digits here. That means 6 has to be here. This is 4. This is distinctly different digits. This has to be... You could have 8, 1, because you can't have 2 and 2. You could have 1, though, here. Oh, so that's how that has to work. So 8 cannot go here, because these have to be distinctly different. Okay. So we have orange, pink, or green. 8 has to go here. So this is 8, this is 1. And this has to have 2 distinct digits. These are the same, but you can't have 2 and 2. These are definitely the same, though. And this can't be 2, so this has to be 3. So this has to be 3, and that's 1. And I think that's the valid shading. Okay. So let's just double check. That's good. Why we double check the previous one. This is 1 distinct digit, 2 distinct digits, 3 distinct digits, 4 distinct digits here. 1, 3, 8, and 4. 5 distinct digits, no 2, 3, 1, 5, 6, 8, and 9. 6 distinct digits, no 1, 2, 3. 7 distinct digits, no 1 and 3. 8 distinct digits, no 1. And 9 distinct digits here. 9 distinct digits here. 8 distinct digits here, no 1. 7 distinct digits here, no 1 or 3. 6 distinct digits here, no 1, 2, 3. 5 distinct digits here, we have 1, 5, 6, 8, and 9. 4 distinct digits here, we have 1, 4, 6, and 8. 3 distinct digits here, 1, 3, 6. 2 distinct digits here, 3 and 5. And 1 distinct digit here, 8. So that's a 1. And that's how you solve it. So that last part was kind of tricky. But maybe that's just because I'm not good with Fillominos. So I didn't really spot that how these had to interact there. Yeah, I'm not sure. I don't do very many Fillomino puzzles except for usually with Sudoku. So I was just interested into seeing how a Fillomino puzzle by itself sort of works. But yeah, it's pretty interesting. I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.